Good day, folks. Welcome to my YouTube channel. This is the electrochemical cell. It says a standard electrochemical cell is set up under a standard hydrogen cell and a standard XX half cell, which is an unknown shown below. A voltmeter connected across the cell initially reads that. So that means they induce the EMF at 0.31 volts when the unknown and the hydrogen react. Right? Now we can see we're given this is negative, that means it's an anode to this unknown electrode, and this one is a cathode because we are given it's positive. Right, it says besides the concentration, write down two conditions needed for the hydrogen cell to function under the standard condition. Besides the concentration, that will be a pressure of what? 101.3 kilopascals, and then the temperature of 25 degrees Celsius. Give two reasons besides being a solid why platinum is suitable use as an electrode in the above cell. So platinum there, it's used because it's inert, which means it doesn't react with the hydrogen, it's inert. Or you can say doesn't react with the H plus, or you can say it's there to conduct electricity. It's there to conduct electricity. Name the component Q. What is the component Q? Is the salt bridge. It's the salt bridge. Write down the reduction potential for SX2. So guys, if this is an anode and this is the cathode, which is the reduction potential for hydrogen is going to be 0. So this one needs to be negative, right? It needs to be lesser, because the cathode it has to have a bigger reduction potential than an anode. So this is going to be negative 0.31. Right? It says write down the half cell reaction that takes place at the cathode. It's the hydrogen. Hydrogen there is what is reduced. So it's going to be 2H plus 2 electrons, and gives you the hydrogen gas. That's what you write. You get it from the table as well. At 8.4 it says the hydrogen half cell is now replaced by the MM2 plus half cell. The cell notation is this. So the cell notation, this is an anode and this is the cathode. Right, the hydrogen cell has been taken out. It is replaced by this metal MM, which is an unknown. Now the initial reading for the voltmeter it's 2.05 volts. It says identify the metal M. Show how you arrive to your answer. We can do that by calculation. So it's going to be 8.4.1. We'll say E cell is equal to the cathode minus the E anode. Right? So the cathode here, what is the cathode? The cathode between the two is the metal X, and the metal X we were asked to identify the reduction potential for that. So it's going to be negative 0.31 minus the anode. Our anode is going to be the metal M, and then the E cell it's 2.05, and then your answer here it's going to be 2.36 volts, right? That's the voltage there. Now in 8.4.2 it says is the cell reaction exothermic or endothermic? Obvious, guys. The galvanic cell is exothermic, right? 8.5 it says the reading on a voltmeter becomes zero after using the cell for several hours. Give reason for this reading, referring to the cell reaction. The galvanic cell is the battery, guys. So after using for a battery for some time, the battery runs flat. So they're asking, why is the battery runs flat? Simply because the reaction has reached equilibrium, or you can say the cell has reached completion, or you can say one of the reactants is used up completely, right? That's the end of the question, guys. I hope you enjoyed it and makes sense, and cheers, bye.